Good morning, students. Welcome to the physics class. Today we are going to start with chapter 8 of your textbook, lesson motion. Let us observe the things around us. If we take the example of buildings, stones, furniture, animals, and human beings around us, we will see that they are either moving or they are not moving. That means they are at rest. So there are two basic states of a body, either rest or motion. Now let us understand motion and rest on scientific basis. This slide shows you a few examples of moving bodies or some stationary bodies. Now let us first find out what do we actually mean by rest or motion. In fact, if the objects do not change their position with respect to time and surroundings, they are said to be at rest, and if they are continuously changing their position with respect to time and surroundings, they are said to be in motion. But every time we require a reference point. That reference point should be a stationary object. This slide gives you a better idea of reference point. A reference point is taken to be as a fixed place. Here, the tree is taken as a reference point. In figure 1, you can see the train is somewhat behind the tree. And in the second figure, you can see the train has crossed the tree. So you can very well observe and analyze that the train is moving. So we can very well analyze the characteristic of a moving body. While we are taking the concept of motion, there is a reference point, and so it determines the starting position of the body. And if the position is changing with the time, the body is said to be in motion. Now here is an example of a moving train carrying passengers. Apparently, rest and motion are the terms which are opposite in meaning, but they are related to each other. However, sometimes it becomes very difficult to say whether a body is in rest or it is in motion. As you can see in the example, a person is sitting in the speeding train. If he compares himself with respect to his fellow passengers and the interiors of the train, he finds that his position does not change. So, he is in the state of rest. But if he compares himself with respect to the trees or the field, etc., outside the train, he finds that his position is constantly changing. That means he is in the state of motion. So we can justify that rest and motion are relative to each other. That means if the immediate surroundings are limited, then the body can taken to be in the state of rest. But if the surroundings are enlarged, the body is in the state of motion. However, no object in this universe is at absolute rest. Let us see this. It is for this reason that we find ourselves in the state of rest on earth with respect to its immediate surroundings. For example, tree, buildings, etc. However, we are in the state of motion if we compare ourselves with respect to moon, sun or the stars, as our earth is revolving and so we are moving with our planet earth. Here are a few pictorial representations of the different types of motion. In most of the cases, motion is complex in nature. The simplest motion is the linear motion, in which the body moves in a straight line. Then there is circular motion, in which the body as a whole moves along a curved path. For example, a car going around a traffic roundabout. Then there is rotational motion, just as the spinning of a ceiling fan. And further, there is vibratory motion, in which an object moves to and fro on its mean position. For example, the strings of a guitar or a simple pendulum. Now, before moving further, let us first discuss the two basic types of physical quantities. They can be differentiated into scalar and vector quantity. The quantities which have only magnitude, that means they are only going to give the values, they are said to be as scalar quantities. For example, length of a cloth. it has no direction. Otherwise, we have the vector quantities which also show magnitude as well as direction. For example, if we say force, that means a force of 10 Newton is acting in the east direction, or it is in the forward direction. Distance and displacement are the terms commonly used to describe the position of a moving body from its reference point. Apparently, they appear to have the same meaning, but in terms of physics, they are entirely different terms. Imagine a boy is at position A and he moves to position C through B. The distance covered by the boy is equal to AB plus BC. That means 4 plus 3 equal to 7 meters. But if we look for the displacement of the boy, it is the shortest length from A to C. So it is equal to 5 meters. So let us have what is distance. It is the total length of the path covered by a moving body. The SI unit is meters and it is a scalar quantity. But if we look for displacement, it is the shortest distance of a body from initial to the final position. Its SI unit is also meter, but it is a vector quantity because it is going to signify the direction also. This slide shows the difference between distance and displacement. As you know, distance is the actual length of the path traveled by the body irrespective of direction, whereas the displacement is the shortest distance between the initial and final position. The distance is always greater than or equal to displacement, whereas displacement is always less than or equal to distance. Distance is always positive, whereas displacement can be positive, negative, or even zero. If we consider the motion of a body, that means the distance covered by the body with respect to time, it can be classified into two types. Either it can be a uniform motion or it can be a non-uniform motion. Therefore, if a moving body covers equal distance in equal intervals of time, it is said to be in uniform motion. For example, an aeroplane flying at a speed of 800 kilometers per hour, or the light energy traveling at a speed of 3 into 10 to the power 8 meter per second, or the hands of a clock. We plot a distance time graph for a moving body in the state of uniform motion. We will see it is going to be a straight line passing through the origin, or it is in the form of a slope. Practically, most of the bodies moving on the earth are in the state of non-uniform motion, as they cover unequal distance in equal time intervals, or you can say equal distance in unequal time intervals. For example, the cars moving in a huge traffic. So, if we plot a graph for a body in the state of non-uniform motion, we will see that it is going to be a curve since the body covers unequal distance in equal time intervals. This slide shows you the comparison between uniform and non-uniform motion. We will cover the first session only till here. So let's get back to the exercise. Students, here is a quick exercise so as to check what all you have understood up till now. Do it in the notebook. If you face any doubt, ask me. Till then, take care and goodbye.